Good morning, my plant-loving friends. Welcome to your Daily Plant Pulse, a podcast-styled series rooted in my deep fascination with plants. Here, plants go through a plant pulse research protocol where we uncover fascinating insights from scientific studies and share them with you. All studies I review are sourced in the description. I'm not a doctor, just someone who loves to research plants and present what I find. Our 9-part series takes you from an introduction to the plant through amazing studies and even an occasional bonus episode. Be sure to check out our Plant Pulse playlist where all of our episodes on all plants will be. And when a plant profile review is complete, explore our Living Library playlist for an in-depth consolidated review. We dig deep into history, forgotten studies, and untold stories so plants can have a voice and their story can be told. Welcome to episode 9, where we dive deep into scientific studies exploring the incredible ways plants can support human and animal health, as well as solve practical real-world problems. There's so much to uncover that this episode will have many extensions. Look for 9.1, 9.2, and beyond as we continue unlocking the hidden potential of plants, largely undiscovered by mainstream society. Until now. So let's dive in. Today we're exploring the wide-ranging health benefits of Diosgenin, a naturally occurring compound found in certain Dioscorea yams. Diosgenin is gaining attention in preclinical research for its ability to protect the liver, calm inflammation, and support multiple organ systems, from the heart and lungs to bones, joints, and even blood sugar regulation. One of the most comprehensive sources on this topic is a recent study titled Diosgenin, an updated pharmacological review and therapeutic perspectives. This review pulls together findings from across the scientific literature and highlights Diosgenin's multi-targeted effects, which we'll walk through today. There are over 100 studies that were reviewed in this pharmacological review. In this session, we'll explore the science behind Diosgenin, define key medical terms and cellular processes, and compare its effects with conventional pharmaceuticals to see just how impressive these findings really are. Let's start with the liver. The liver is a vital organ responsible for filtering toxins, producing essential proteins, and regulating metabolism. Chronic liver injury, whether from alcohol, fatty liver disease, or viral infections, can lead to fibrosis, which is the formation of excess scar tissue. Fibrosis disrupts the liver's normal structure and function, eventually progressing to cirrhosis if left unchecked. Researchers have tested Diosgenin in laboratory and animal models to understand its liver protective or hepatoprotective effects. In one study, human liver cells were artificially triggered to mimic fibrosis. This is important because fibrosis involves overactive liver cells producing excessive collagen proteins like alpha smooth muscle actin, which are markers of scarring. When Diosgenin was added to these cells, it reduced collagen production, moderated cell overgrowth, and calmed key signaling pathways, known as TGF-beta and SMAD3. In simple terms, Diosgenin slowed the formation of scar tissue and prevented liver cells from going into overdrive, helping to preserve healthy liver function. Another study focused on alcohol-damaged liver cells and animals with alcohol-induced liver fibrosis. Here, researchers used diosyn, a derivative of Diosgenin. The results were equally compelling. Liver condition improved, inflammation was reduced through the TLR4, MyD88 NF-kappa B pathway, and damaged tissue began to repair. These pathways are central to inflammation. NF-kappa B is a transcription factor, which means it helps turn on genes that produce inflammatory molecules. By calming this molecular switch, Diosgenin and diosyn effectively reduce the inflammatory signals, driving liver damage. Across these studies, no effect that was toxic was reported. At the dosage tested, meaning the compounds were all tolerated by the cells and animals studied. But the benefits of Diosgenin extended far beyond the liver. Preclinical research shows it has multi-system protective effects, supporting the heart, lungs, thyroid, blood sugar regulation, bones, and joints. For example, in studies on cardiac fibrosis, where heart tissue develops scar-like proteins, Diosgenin reduced scarring proteins and slowed the overgrowth of heart cells. In pulmonary hypertension, a condition of elevated blood pressure in the lungs, Diosgenin protected lung tissue from inflammation and damage caused by toxins and bacterial triggers. For thyroid support, studies in mice with Graves' disease showed Diosgenin could lower excess thyroid hormone levels and reduce thyroid gland size. In models of diabetes, Diosgenin improves blood sugar control, reduced LDL, cholesterol, and increased antioxidant enzyme activity. For bone health, Diosgenin increased proteins that protected against bone loss, and in arthritis models, it reduced joint inflammation and prevented cartilage cell death. In a model of cardiotoxicity, Diosgenin protected heart cells by reducing oxidative stress and inflammatory signals, demonstrating its broad protective capabilities. Let's pause to define a few key terms here. Cytokines, for example, are small signaling proteins released by immune and other cells. They act like chemical messengers, coordinating inflammation and immune responses. Inflammation itself is the body's attempt to repair damage or fight pathogens. But chronic inflammation, such as in liver, fibrosis, or arthritis, can be destructive. NF-kappa B, a transcription factor mentioned earlier, is a master regulator of inflammation at the molecular level. By reducing NF-kappa B activity, Diosgenin lowers the production of inflammatory molecules, which helps to prevent tissue damage. Another key concept is fibrosis. Fibrosis is the buildup of scar tissue in organs like the liver or heart. Proteins such as collagen and alpha smooth muscle actin accumulate and alter organ structure. By reducing these proteins, Diosgenin helps maintain normal tissue architecture and function. Now, how do these preclinical findings compare to conventional pharmaceuticals? Drugs that target fibrosis or inflammation, such as corticosteroids, immunosuppressants, or liver protective medications, can be very effective but often carry side effects. Corticosteroids broadly suppress the immune system, increasing increasing risk for infection. While immunomodulators adjust immune responses, but may have liver toxicity or long-term dependency concerns. Statins, commonly used for cardiovascular support, primarily target cholesterol but don't directly address fibrosis or tissue inflammation. Basically, what we're dealing with is a lot of symptom modification, but not necessarily treating the actual underlying cause. Diosgenin, in contrast, acts as a multi-targeted way. It reduces inflammatory cytokines, moderates transcription factors like NF-kappa B, limits scarring proteins in organs, and improves tissue repair. These effects span multiple systems simultaneously, something that often requires several drugs in conventional medicine. The absence of observed toxicity in preclinical studies is particularly noteworthy, making Diosgenin a highly promising candidate for complementary health support. While it has not yet become a replacement for pharmaceuticals, it demonstrates a natural multidimensional mechanism of action that is impressive in the context of preclinical research. To summarize the findings, Diosgenin protects liver cells from scarring and overgrowth, calms inflammation, supports tissue repair, and benefits multiple organs, including the heart, lungs, thyroid, bones, and joints. The doses used in animal studies range from very small microgram levels in cell studies up to 130 milligrams per kilogram. in animal models. Depending on the condition, delivery methods vary from direct application to cells in lab dishes to oral or injected administration in animals, which were seen as very effective. Across these studies, no toxic thresholds were reported, meaning the compound was well tolerated. It's worth emphasizing that all of this research comes from lab and animal studies. Human trials are still needed to confirm safe and effective dosages, as well as the extent of benefits in people. However, the current evidence paints a compelling picture of how a natural plant compound can support the body at multiple levels, working with the immune system, calming inflammation, protecting cells, and promoting tissue repair across several organ systems, and yet still not be studied for over 70 years effectively. This is just the beginning. In the next episode, we'll dive deeper into how Diosgenin may show promise, at the very least warranting further research in cancer treatments. And we'll ask the big question, does Diosgenin safely and effectively target cancer cells without damaging healthy tissue? Stay tuned for part 7 in our ever-evolving Yam Episode 9 series, where we review studies with amazing results. The Pulse continues.